meters tall.
Question 8. Giraffes are the tallest terrestrial animals, growing up to 5 meters tall. Approximately half of a giraffe's height is due to its long neck. Modern giraffes have evolved from ancestors with much shorter necks. The figures represent two different hypotheses regarding the evolution of the giraffe's long neck. You have the competing browsers hypothesis, and they're showing a giraffe browsing, and necks for sex hypothesis, and you've got a rather fancy, weird looking shaped giraffe angle. Okay. Charles Darwin suggested that the long necks evolved by natural selection. Longer necks allowed animals to feed higher up trees with less competition. This is the competing browsers hypothesis. This hypothesis was not thought to be consistent with all the evidence available, and a rival hypothesis, necks for sex, has been put forward. This suggested longer necks have evolved as a result of sexual selection through male-male rivalry, where male giraffes fight for access to females by standing side by side and hitting each other with their heads. Okay, right. Use the competing browsers hypothesis to explain how long necks evolve by natural selection. So they're basically asking you to give the process of natural selection, but you have to be careful that it's actually about this. So you have to relate it back to giraffes. So what we're looking for natural selection is just selective advantage, and then we want more successful at passing on genes. Okay, so more successful or fitness of offspring. Okay, so we need to link that to the competing browsers. So what you'd say is that those with longer necks got more food, so therefore increased survival due to that selective advantage, and their offspring would be more successful again, so increasing fitness of them. There we go. Okay, B. Long necks evolved around 13 million years ago when much of the African forest was replaced by grassland with a greatly reduced number of trees. Explain how this supports the competing browsers hypothesis. Well, so basically what they're saying is you had loads and loads of grass, and then it was loads and loads of forest, so lots of trees, which then was replaced with grassland with a few trees. So taller browsers would be able to get more nutrition, and that's basically it. So therefore that would mean that they've got a selective advantage if they're taller, and that will drive the natural selection of it. Okay, explain how long necks could have evolved through sexual selection. Okay, so sexual selection, what we're looking for there is that you have a male-male rivalry which affects the female choice with regards to reproduction. Okay, so a longer neck may have meant that they were more successful in their smacking heads against each other, and therefore females would be breeding with those with longer necks. Okay, so it's basically the same idea of what you're saying for the competing browsers. It's still selective advantage, but this time we're talking about the access to females being determined by the length of the neck. Okay, a study published in 2013 concluded there was no sexual dimorphism in neck length in giraffes. Suggest how this finding would cast doubt on the necks for sex hypothesis. Right, so sexual dimorphism, what you're looking for there is that the males, almost always, are competing for the females, and so therefore they are the ones that you're looking for being bigger, brighter, things that you would see. And the females therefore should be less of that. So what you'd be saying is, if the females are not shorter, then that doesn't support that hypothesis. Okay? Because if it was supported, then the male necks would be longer. So you need to link it very specifically to the male and female giraffes and the length of the neck, and that's it. And that's the question.